Ma'am, you did not connect your audio. If you're speaking, we cannot listen to you.
Hello. Hello.
Yes, ma'am.
Yes, ma'am.
We can hear you.
Keep on asking. Okay, fine.
Okay.
Shall we start? Let us wait for some more time.
We'll start, ma'am.
Okay, fine. How many of you are there?
7, ma'am.
7, ma'am.
All regular candidates have come?
Dalia, Durgesh, Sayan. Asha is
Asha did
not
not
there.
come. Asha did not come.
Asha, Harshita. These both are
Yeah,
not.
Harshita also did.
Because we are going to talk about that yesterday's homework. How many of you have done that homework?
I have done, ma'am.
Okay, Nibia. Then anybody else?
I
Durgesh?
didn't attend only, ma'am.
Durgesh has not done? Today is only biryani day. No, yesterday was not the biryani day, isn't it?
Actually, I was not there, ma'am, yesterday. Today I will do it, ma'am. Today I will do it.
Yesterday's homework today will do. So today's homework next week you do, huh?
No, ma'am, today actually I got free, ma'am. I returned morning itself.
So, okay.
Asha is also back, ma'am.
Okay, very good.
Can start.
Okay, so shall we start?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, I'll start. Only 2 people have done this homework, isn't it?
Yes, ma'am.
Okay. Yesterday, how many people have attended the class?
12, I guess, ma'am. I don't remember actually.
Ma'am, homework question is what is filtration and what is absorption?
No, filtration and percolation.
Percolation.
And perforation, na? Filtration and perforation.
Percolation.
Percolated. Okay. I say everyone is ready. Shall we start?
Yes, ma'am.
Yeah, ma'am.
Okay. What is meant by now? Actually, two people have done this homework. One is Nubia, another one is Asha. Any one of you start first. You start. Nubia, start.
Start to thought, ma'am. Okay. Filtration, ma'am. It means the act or process of filtering through mechanical separation of a liquid from undissolved particles floating in it. And percolation is seepage or filtration of liquid through a porous substance.
Please stop there itself. Every one of you got it?
Yeah, ma'am.
Yes, ma'am.
What is meant by filter and what is meant by filtration and what is meant by percolation? What is the difference between these two? Another thing I would like, anyone can explain what is the difference between these two? No one hear it apart.
Maybe heard, ma'am.
Now we read out one more time slowly about filtration this, about percolator this, like that you read.
Okay, ma'am. Filtration, the act or process of filtering through mechanical separation of a liquid from the undissolved particles floating in it.
Did you understand? This is the separation of undissolved particles in liquids by mechanical process is called filtration. Clear?
Yes.
Yes.
Every one of you got it or not? We are wasting the time, but I wanted to know, make you people to understand this concept. Yes,
Yes.
ma'am. Okay, filtration means now it must be very clear. Then what is meant by percolation?
The seepage or filtration of a liquid through a porous substance.
Okay, that is separation of liquid from the solubilized, undissolved salt is called filtration.
Yes.
This is, we can say percolation, which is means just it is seepage. It is flowing through the porous media. It is called percolation.
Yes, ma'am.
Understood? Clear?
Yes, ma'am.
Yeah,
And
ma'am. Yeah, ma'am.
filtration occurs fast, ma'am. Percolation, it occurs slowly. And
Yeah,
percolation occurs into rock also, ma'am.
yes.
Not only soil.
That is not a separation process. Percolation is not a separation process. Filtration is the separation process. That is the main difference. I wanted to make you to understand yesterday that only.
Yes, ma'am. Percolation is just the slow passing of these liquids.
Through the porous media.
Yes, ma'am.
Okay. Filtration means you are separating or removing something, some solid from the liquid. That is called filtration.
Yeah.
Ma'am.
Clear? Okay. If the question will ask in the end, this question we have more than 1,000 or million times of come in many examinations. Okay. If this question will come in, I think these 9 people should not make mistake. I feel. Understood?
Yeah.
Okay,
Yeah.
ma'am.
Okay. And then next word. Nubia, read out next.
Read out what, ma'am?
That's all or anything more you have?
No, ma'am.
That's all.
Yes, ma'am. Downward filtration is downward movement of water into soil, and percolation is downward movement of water into rock and soil. And filtration occurs on subsurface and surface of soil. Percolation occurs underground.
Okay. These are all not make that much difference. Both are similar only.
Yes, ma'am.
Any other point, Asha ma'am, do you have?
No, ma'am. All are covered, ma'am. It's
covered.
same only from my side
Okay.
also.
Okay. Thanks to both of you. And I advise to all of you all the best. If this question will come anywhere in your lifetime you are facing, please be strong on this concept. Okay. Okay. Then we will enter into the subject. Where we left, remember now, without looking at the book.
Viscosity of water we ended with.
My God. We have covered that also. Then design of the unit we have come. There
Ma'am,
are
we
three-
completed plain sedimentation. What is plain
yeah,
sedimentation?
the plain sedimentation we have covered.
Yes, ma'am. Retention
then-
period also, ma'am.
Yeah, yes. Okay, that the design and the formula is very important. Detention time equal to length into breadth into depth divided by flow speed.
Of
You
water.
remember, you write that formula. If you write that formula, people will be flattered that, oh, the student is studied well like that. They think.
Okay, ma'am.
Okay. And L is greater than or equal to 4B also you have to write. Then you have to describe that L is length, it is 4 times bigger than, larger than breadth will be the ideal for rectangular type of sedimentation tank. You write like that sentence. Clear?
Okay, ma'am.
Okay. Then we'll go for sedimentation with coagulation. What is the difference with now? Till now we have seen plain sedimentation. Whatever the concept involved in plain sedimentation, the same concept involved in sedimentation with the coagulation also. Only one thing is different. Here we are adding some extra chemicals to settle down more particles. That is only the difference. Okay. So again, I don't want to define, but this is the final time I will tell you. You people get or not, then you tell. Actually, very fine particles. Those particles are called colloidal particles. Those particles very, very smaller, and they are a little heavier than water, but that the particles are very fine particles. They won't be settled down by the natural or plain sedimentation. But anyhow, we have to remove those particles from the water by adding on some chemicals are called coagulant. When we are adding this chemical to the water, whatever the small particles are there in the water is aggregated to bigger ones. Then those particles have settled down eventually. That process is called coagulation. When we are adding this coagulant, a precipitate is formed that is called flag, which will be settled down at the bottom of the tank. That is called a flagellation process. For that entire process, the time taken is varied from 2 to 6 hours. That is the detention time of this particular process. So I have told you many times in this class, what are the coagulant people are using for this water purification process? Anyone can tell, please?
Alum, ma'am.
Alum. Then
No.
Aluminum.
aluminum cannot be used directly. Alumina can be used. Alum means aluminum sulfate. Alumina means aluminum oxide.
Ma'am, chlorine, iron.
Ferric-
Yes, ma'am. Iron
ferric-
salt.
ferric sulfate.
Iron, ma'am. Iron.
Yeah, some of the iron or ferric salt, then ferric chloride, ferrous sulfate.
Ferrous sulfate, ferric chloride.
Those
Aluminium
things can be
sulfate.
used.
Alum.
Aluminum sulfate, which is nothing but alum.
Alum.
Alum means which is not, this is a common name. Aluminum sulfate is
Yeah.
chemical. Okay. So these chemicals are commonly used for this water purification purpose, especially in coagulation process. Those two salts are having a different distinct quality, but both the chemical can be used. When the water is alkaline condition, you can use iron salt. If it is an acidic condition, you can use alum salt. Further, when we are using alum, further it reduces the pH into acidic level. So liming process is essential whenever the alum treatment is being given to the water. If we use this ferric salt, that will be whenever the water is alkaline condition can be used. But there the pH is a matter. In acidic pH, what alum, what could be used? In alkaline pH, what could be used is this. Whenever the pH is between 6 and 8, you have to use alum salt. Whenever the pH is between 8 and 10, that time you have to use iron salt. The pH is a crucial role to select this coagulant. Okay, if you are taking a wrong coagulant, the process efficiency will not be coming up, because around the 90 to 95% of potability can be removed by this coagulation process, and which removes around 78% of bacteria also. I have done this process practically. That's what I'm doing. Okay, but another thing, this alum is giving always a heavier, quick, and faster settlement than the sulfate salt. And when we are using these chemicals for water treatment, how it could be used? Because we are adding simply salt into the water. When it will be dissolved, when it will be mixed, when the process will happen. When we are thinking like this in the large scale operation, it's supposed to be feasible to operate. So those chemicals either can be used in the powdery form or liquid form in a desired concentration based on the water characteristics you have to prepare and store. And when the treatment is going on, you have to add into the water. And after adding of chemicals into the water, the very important process in coagulation and flocculation is mixing. Because for making a flag, it is flocculation. The flag is formed after mixing only. So the mixing is an important stage to provide the efficiency of the process. How they are mixing the chemicals and the water, how they are doing the mixing, that's what we are going to talk now. Because in the last class, when we have studied the different stages of treatment, we have studied how to add coagulant into the water. We have studied. Could you remember?
Yes,
Powder
ma'am.
form,
Yes, ma'am.
liquid form, how we have added, we have seen. Now, after adding these chemicals, how we have to mix, that is very important. If we are not mixing properly, in some of the part of water it is not mixed, means whatever the particle dissolved in that particular portion of water will be lying as it is only. Then when we are checking the water quality, you will blame on the chemical just by a particular coagulant not giving or not removing the turbidity to this much percentage. So to avoid all those things, the mixing of coagulant with the water is very important. This process in another name it is called flocculation also. Because of mixing only the flag is formed. So mixing comes flocculation will be mentioned in water treatment process. Okay, how they are doing? The coagulation solution in such a thing, already told you that it is desired with the desired length, it is prepared and it is stored in a vessel. And this feed into fed into the mixing basin by the help of feeding devices. The rate of flow of coagulant solution is maintained constant always by suitable arrangement which is proportional to the rate of flow of water. Then after that, the mixing is done in the mixing basin which is separate, which may be two different types. Either it is buffle type and mechanically agitated type. From the name itself, we can differentiate. Buffle means there is a kind of buffle will be fixed in the walls. The water flow is being maintained in a zigzag flow which is going up and down and through the buffles, and the end the mixed solution will come out. How they are doing in a buffle type mixing basin, which is always in rectangular shape only. Either it is flask mixture, mechanical device, or this buffle type, both are rectangular type. In this tank, the bubbles are provided. That is, bubbles means which is nothing but in our old water filter, there is inside the white color column inside. No, do you remember?
Yes, ma'am.
Like that kind of bubbles, many things will be available in the rectangular type of container. When the water enter, that is up and down will be there. One is from the vertical, from the top to bottom. Another one is from the bottom to top vertical, like that. So from one to another bubble, there will be a gap. For everything, there is a standardized length and the gap will be there. They have to follow accordingly. Only one thing, they have to maintain the constant speed around the 30 to 40 meter per second, or sometimes they are maintaining velocity of around 40 centimeter per second also. The velocity is very important for mixing process. And what they are containing proper inlet and outlet. Through the inlet, they are feeding the solution, both water and coagulant solution. When it passes through, that n number of passes through means not inside the bubble. When the bubble is there, up and down it will be there. The water is flowing like this zigzag manner, and when it comes out through the outlet, it is properly mixed well with the chemical. So this is the concept. Either it may be up and down type, or it is horizontal flow type. The water will be flowing with the chemicals. At last, when it comes out, it is totally mixed. The matter here is they have to maintain the velocity only. Around 45 centimeter per second is enough maximum. How much minimum you can get to below 45, it is okay. But you have to fix the rate of process according to the demand of water. And another one is flash mixer. Flash mixer, which is nothing but a rectangular type of container or tank, which provided with a impeller. Impeller means what? Anyone can tell me? What is meant by impeller or agitator?
It stirs the liquid, ma'am.
Yeah, steering the liquid.
Once again, ma'am, what is the question, ma'am?
Impeller. What is meant by
Yes, yes.
impeller or agitator?
Agitator which adds in mixing, madam.
Yeah, we're talking about the mixing only. Yeah. You have an idea about impeller or agitator or steerer?
We have never seen them, ma'am, but we know what they are.
Okay, understood. How your mixer jar is working, not mixer machine. Mixer jar is working. And you can say total mixer, how it is working. Why that is called mixer first? Mixer jar,
Ma'am,
we are
it's like a frother, ma'am. For coffee making, frother is used, no, ma'am?
coffee making, it is mixing is taking place, but that is not proper mixing.
No, ma'am. There's a different instrument for just to make froth.
Yeah, that is also there. For a bit of egg, that kind of process we can consider. A very simple example, and everyone aware that is mixer grinder and baking. Why that is called mixer grinder? It is a grinder they have to say, otherwise they have to say mixer, but they are using the same term.
Because it mixes also, it grinds also.
Yeah, that is
Mixes
the
and
reason
grinds,
they are
ma'am.
That is mainly we are using the device for grinding only, not for mixing most of the time, isn't it? Very rarely we are using that unit for mixing. I'm correct or not?
Yes, ma'am.
Yes, ma'am.
Okay. Similarly, you take some container in that. At the middle of the unit, you provide some pedals. Pedals means when you are making that fruit juice, when you are making the chutney, what is the difference between these two? Anyone can tell me, please? Both are having the blades. Both
Yes.
are jaws. Both are using the same mixer grinder only. But what is the difference between these two operations?
Ma'am, turns
The-
per minute.
Okay.
Yeah.
RPM is different.
Ma'am, size of the jar also. Ma'am, size of the jar also.
Okay.
Ma'am, the nature of the object, ma'am, means the hardness.
That is the point. That is the point. Okay. You look at your both the jar, whatever the difference you said, that is correct. Absolutely correct. I am agree with you. When you are grinding the chutney, there is a possibility of occurring some dead spot while you are grinding the chutney in the small jar. Okay. Even if you grind for hours together continuous, also it will be. But in mixed fruit jar, if you run for a few minutes, there will be a dead spot. If you run over a longer time, there will not be any dead spot. Understand? The object they have provided at the middle of the jar in the form of blades, which plays in such a role, which is blending and grinding. Another one is only grinding. Understood?
Yeah, ma'am.
No sound at all. Everyone feeling hungry.
Yeah, ma'am. Yeah, ma'am.
Yes, ma'am.
Hungry.
Yes, ma'am.
No, ma'am.
Okay, fine. So that is the concept. Here, the same impeller is working such a way. In the middle of the unit, they are providing some sort of pedals. The pedal will be rotated by control, or pedal rotation will be controlled by the motor, which is connected with the electrical power. And what they are doing, already the water is being filled in the container. Then they are adding the coagulant solution just below the pedals. Then when you are rotating the pedals, the bubbles are provided. The water is entering through side wall of the container, or in between the bubbles and the wall. The water is coming just below the bubbles, and the blades, or pedals are being, the level of pedal and the level of bubbles are not same. The bubble supposed to be little higher than the pedals. Pedals supposed to be in down level. The coagulant is entered just below the pedal. The water is entering just above the pedal. Because of this rotation of pedal, the water and the coagulant in the mixed well, Then the mixed solution will be drained out through the outlet. This is the flash mixture people are using in research level. In the large scale commercial purpose level, whatever the bottle type we have seen earlier, that we are using. This type, it is process wise, it is highly effective. But when we are using at the large scale level, it is quite difficult to operate. Sometimes what will happen, if we add coagulant solution, no problem will come. If you add the coagulant in the form of powder, it will be making some lumps. To avoid that, people are using solution only, but even then operation, maintenance, cost, operation, matter, everything altogether which goes up. So pedal types are suitable for this purpose. Clear? But here, this impeller are very important point. We have to, when we are rotating the impeller, it's reverse at very high speed. Anyhow, it is something like a mixing process. Followed by this, we have to settle down the coagulant along with the waste particles. How people will do? So the impeller is rotated between the speed of 100 to 120 RPM only. This process will be done for 2 to 3 minutes with detention period. This is crucial for running or doing this particular process. Moreover, the raw water is allowed through the inlet and the deflector or the pedal will be guide the water towards the rotating impeller. The water and the coagulant are thoroughly mixed and the water is discharged from the outlet. Whatever the sludge is formed from this particular unit, it will be drained out from the bottom. And when we are taking out the sludge, it should not be disturbed the rest of the process, because these are all continuous process, not batch process. What is the difference between the batch and the continuous process?
Batch, ma'am.
All
Continuous
the
process.
water is continuously.
For example, I said this pedals at the middle, you are running the pedals by motor and you are feeding the water from side the wall, you are in between the what is that called, bubble and wall, and you are adding the coagulant solution just below the pedal. When you are rotating this pedal, water and the coagulant solution will be mixed. So after mixing, it is discharged from the outlet, and whatever the sludge is formed from the process will be discharged from the bottom through the outlet, I said. The same process people are doing continuously. How it could be possible? I didn't say that is batch process. I said it is a continuous process. How it could be possible? Is it possible first? First
No,
question.
ma'am.
Second, but no. What is meant by continuous? What is meant by batch process?
Ma'am, continuous means it does not stop, and batch means in different batches it has to be done.
That's all.
Intervals, specific intervals of time.
Yeah, correct. That is correct. That's what I wanted to know. How you people are. Continuous means the feeding also continuous and the production also continuous. That means inlet and outlet both is supposed to be continuous, isn't it? If one thing will stop, the entire thing will be stopped. Both should not be stopped. That is continuous process. Batch means you feed everything, you do it and take it out, stop it. Then again you feed it, do it, take it out, stop it, like that. It is not like that. When this kind of process also, when they are doing that continuous, the feeding level and the mixing rate is supposed to be coincided according to the flow of outside or outlet flow. Understood? For example, the mixing time, how many minutes I said? 2 to 3 minutes only, isn't it? Could you remember?
Yes, ma'am.
2 to 3 minutes you wanted to mix means the solution which you are feeding into the system, it's supposed to take in such a way it maintains 2 to 3 minutes at the bottom of the pedals. So the flow from the top to bottom through the inlet is supposed to be maintained in such a way. Clear?
Yeah,
Yes, ma'am.
Okay, like that only all the industrial setups are working. Most of the industrial process, most of the industrial production is continuous process only. Only for few products and few industries are carrying out by batch process. Otherwise, our population is increasing like anything. Today, the soap requirement 1 million, tomorrow it may be 1.5 million, the day after tomorrow it may be 2 million. For example, if I will say, if they are doing the batch process, is it possible? No.
No, ma'am.
Now, likewise, you just think about the milk. Now, if today tomorrow is a festival day. Tomorrow is any festival you take, for example, New Year comes. New Year means everyone will celebrate. So New Year will take. Tomorrow everyone will make some special item. So there will be a requirement of more ghee, more milk, more sugar, and the rest of the things. More it is required on that particular day.
Yes,
We do not know how much they are selling, how much they are getting, how much they are producing, but how much the demand is there. We know only how much it's there at home, how much we need to buy. These two only we know, isn't it? But people are meeting the demand on that particular day. How they are meeting? You may consume, instead of one more milk packet, you may consume 2-3 packets on the same day. Everyone do like that, no? So in the total city, it is demanding like that. How the city people will meet the demand? How
The
they
mixing
will
mixing they will do.
But the producer made more, ma'am. Production is done more.
That means
Mixing.
cow or buffalo will give more milk on that particular day.
No,
No,
ma'am.
ma'am,
We need like
they'll
that.
mix. Mixing will be done, ma'am.
Mixing
of
of
water with milk.
My God, every day you are getting the same water milk packet only, no? My God, company people will meet us. How they are meeting the demand? My question is correct, isn't it? In New Year day, if people use instead of 1 milk packet 4 means the cow or buffalo give 3-fold of milk yield or what? No. Isn't it? That yield is more or less less than that on the other days, because the people, those who are taking care of them, will be busy with the celebration of New Year. They won't take care much. The yield must be less only. That practically I have seen and telling. All festival days, all this kind of animal yield less, because they won't give much attention on them. And in many villages, there's a milk buyer won't buy milk also from the people to sell, because they have to go away to sell. If he also wanted to celebrate, he will not go. That also I have seen. But we are consuming more. How is it? Hey, people are in this world only, na? Not in the Mars, na? How it could be possible?
Storage.
Storage only is possible. Nothing else can be done, isn't it?
Yes, ma'am.
So whenever the production is more, huh? What are you saying? Storage, how they are doing milk storage? How it can be stored?
Buffer.
How the milk can be stored?
Freezing.
Freezing. Simply
The sterilization.
Okay.
Sterilization and pasteurization.
Pasteurization is the point. Okay. You see your milk packet, pasteurized milk will be written or not in all the milk packet you check it. If
Yes,
it is
ma'am.
not written means that is duplicate milk, you can return back.
Okay, ma'am.
Okay. Pasteurized, they are doing storing by pasteurization process. Then only they can meet the demand. Not only milk like that, many products are doing, including our toothpaste, soap, oil, everything are doing like that. Sometimes, someday, suddenly the demand is more than how the people can meet the demand. That is only the way they can do. Whenever it is available, that time they store like water in them, and they will distribute whenever it is not available. That is the basic concept. But each and every product, there is a different technique is involved for storage. That is the point. We have to thank the respective department researchers. For vegetable, how to store, how to store, for rice, how to store, for milk, how to store, for oil, how to store. Different techniques are adopted for different products. They adopt the right technology, right technique to store the different products. So likewise, when they are doing this kind of process, also they are doing continuous mode. The continuous mode here, it will be maintained through the flow rate only. Nothing else can be done. That is only the technique will be adopted to maintain the continuous operation of mixing. Mixing is an important process, which is nothing but the coagulation process. How it is involved in the entire treatment process, we'll see now. Now, factors, what are the factors can be affected this coagulation process? What is coagulation? Why we are doing coagulation? What is the purpose of coagulation?
To remove solid particles,
To
ma'am.
remove
To improve the
waste
quality
particles.
of quality.
Dead particles or solid particles.
Okay. Now you are doing PG students, you are middle of the year, you have to talk technically. Okay. So what I am going to tell you, please listen. Whatever you said, correct. But the exact term we have to remove for doing this coagulation process is to remove that turbidity, isn't it? To remove the turbidity or not?
Yes,
So
ma'am.
the
Yeah,
particles
ma'am.
which are in suspension, we are removing that is turbidity, and we are removing the color also. I told you whenever you are adding this alum, that will be remove the color also. I told you, isn't it? To remove the color, and which
Yes,
reduce the organic and inorganic impurities because which absorb the particle from the water, and which reduce the 75% of harmful bacteria. I told you. Substances causing unpleasant smell and taste like a phenolic compound and iron oxide also will be removed by this coagulation process. So these are all the purpose of doing the coagulation process. Now you please answer to me, what are the factors could be affected the coagulation process? From my answer, you can pick up and tell no.
Ma'am, color, water quality,
pH,
yes.
Temperature.
pH, quality,
Temperature, pH,
quality
and
of-
all I said. Now you people can tell that.
Chemicals
type of
that are put
coagulation.
into it, ma'am.
Okay. Now what we have discussed last. Before I am asking about the factors, what process we have discussed in the last minute of today. Now,
Mixing.
Mixing.
that is the important
mixing.
process which affects in the coagulation process, isn't it? I
Yes,
told
ma'am.
you some dead parts is
Yes, ma'am.
occurring. There the particle is not removed means that the entire water quality will be affected. I said, isn't it? Sir, no.
Yes, ma'am.
Yes,
Yeah, ma'am.
ma'am.
Okay, now I'll clarify to you. Please listen me carefully. The factors which affect the coagulation process is amount, color, and turbidity of water, type of coagulant we have selected for the process, quality of water, the pH of water, the temperature of water, time of mixing and flagellation, and the intensity of agitation. These are all the process which affect the coagulation process efficiency. Is it clear?
Yeah, ma'am.
Yes, ma'am.
The dosage of consumption, we are talking about the coagulant, alum, ferrous salt. How much we could be added into the water? For example, the quantity for alum or iron salt, which is in the range of 0.3 to 0.15 gram per liter of water is enough. If greater than the turbidity, it requires more quantity of coagulant, and the temperature about the pH already I told you, more than the temperature, that the coagulant requirement is less. If less the temperature, it's more coagulant. About the pH already I told you. Okay. Then
Yes, ma'am.
next one, sedimentation with flagellation. Sedimentation with coagulation we have done. We have seen. In that, what we have seen, what are the chemical coagulant we are adding, how we are adding, how we are mixing, and what are the factors affect the coagulation we have seen. Now, the same way we are going to see sedimentation with flagellation. Flagellation simply will say, what could be, how could we define this flagellation? Please tell me how it could be defined. Flagellation means what? Flagellation means what I said. After adding the chemical, we have to mix, isn't it?
Slowly, yes,
Yeah.
ma'am. It is mixing the
After mixing, the flag is formed. That is called
The flag
flagellation.
is formed.
flagellation.
Flagellation. Yes.
Which is nothing but flagellation is a slow mixing process in which whatever the destabilized colloidal particles are there in the water will be brought into the intermediate
It creates
contact.
a larger one, which is easier to separate.
Yeah, to promote their agglomeration or aggregate into bigger size. That's all. That is called flagellation. Clear? Shall I tell one more time? Flagellation, which is nothing but
No,
a
ma'am.
slow mixing process in which These stabilized colloidal particles are there in water or brought into intimate contact with each other, which promote their agglomeration or to aggregate into the bigger size. Clear?
Okay, ma'am. Yeah.
No one is there in
Yes,
class.
ma'am.
Okay.
No, ma'am. I have to unmute and say no, ma'am.
Yeah, ma'am. Yeah, ma'am. Clear, ma'am.
The flagellation process, from the process itself, we can say that what are the physical and chemical parameters which affect the flagellation process. They are the physical process are factors like time of flagellation, velocity gradient, concentration of particles, and the chemical parameters such as alkalinity, pH, and a type of coagulant we have chosen for the process. These are all the factors affecting that flagellation process. And each and every parameter, there is a constant or a fixed or standard value for this process. For example, this mixing is in the range of 30 to 60 seconds we have to follow, and the range of velocity gradient supposed to be maintained between 300 to 1200 per second, and also rapid mix we supposed to give there that velocity gradient between 10 to 80 seconds per second, and time of flagellation and the velocity gradient for that process is supposed to 10 to the power 4 to 10 to the power 5. These are all the fixed constant standard values supposed to be adapted for this flagellation process. And whenever the turbidity is more, the more efficient is the process of flagellation by adding super or fine coagulant, which is not the coagulant, sorry, flagellation. The flagellation is nothing but the slow mixing of process in which these stabilized colloidal particles are brought into intimate contact with us to promote their agglomeration, that is called flagellation. This flagellation process depends upon some of the physical and chemical parameters. What are the physical parameters, chemical parameters we have seen? Each physical and chemical parameters are operated under a fixed condition only. There is no change. If you are changing anything, there will be a stop in the process. If the turbidity is more, the efficiency of the process more. In rest of the process, if the pollutant is more, means which may affect the process efficiency, but in the flagellation process, it is vice versa. It is in a reverse manner. If the pollutant more, pollutant level is more, means it improves the efficiency. So this is about the flagellation. Now, I told you that it is a slow mixing process that is called flagellation. So how we'll give the mixing to this flagellation process is an important factor. There are different types of mixers are available, or mixing units are available for providing this mixing in flagellation process. That is mechanical mixture, diffuser and injection devices, inline blenders, and hydraulic mix. These four types of mixing people are generally adopted for this flagellation process. So how this mechanical mixer is working? This mechanical mixer is a very common type everywhere people are using, which is nothing but whatever we have seen, color or agitated type of mixing, that only. Here the contact time in each and every such a devices which reduce the increase in the velocity gradient, and in such a way the mixing is taking place. Diffuser and injection device, I don't want to explain more, because here a diffuser means you know what is meant by injection devices means you know what is, but how it is working is there is a series of tubes with orifices or nozzles are used for this. Through that they are producing the turbulence in the mixing, and which makes the turbulence in the downstream, and the coagulant is fed into the orifices when the mixing is taking place. Then other things, the parameters is it can just go through each and every physical and chemical parameter give for all the design, you just go through. And the another one is inline blender. Inline, from the name itself we can understand, which is something like instantaneous mixing device, which does not require any sort of mechanical or electrical power, but which requires no head loss computation. It can be operated very less cost for any local or rural people also can adopt this particular technology. And the hydraulic mixing, this is very costly way of doing the mixing. They have to produce the hydraulic jump we have to make by providing that mixing pumping. So the hydraulic jump provides the turbulence in the inside. Because of that, the mixing is taking place. Other than that, people are using some recirculating pump also, but widely they are not using this much because which produces more head loss. So mixing means just we are mixing the content without affecting nature of the substance. If it is change the nature of the substance, then that will not be adapted for any process. For example, you are mixing the coffee, which will affect the nature of the product of any stream, either milk or water or sugar or coffee powder. Any of the stream characteristics is spoiled or affected or changed.
No, ma'am.
So that means you are just mixing and having, like that here also you are just mixing and leaving for second. That mixing how you are doing, that is the point. So these four different methods people are adapted for the mixing of coagulant with water, that is called flocculation. And the next one is flocculators. Flocculator means what? Which is nothing but a rapid mix device. That's all. That is called flocculator. It helps in building up dense and large size flux which in turn settle down quickly in the clarifier or at the bottom, that is called flocculator or another position. Some people, they have given some sort of expression to find out the orthokinetic flocculation. You people, if you want, you can read, otherwise you can neglect also, no issue. They have given two different equations for that.
We don't have to write this in exam, ma'am, if they ask.
You can write a flocculator and if you write also any one equation, right? This is the equation will be used for a particular either velocity gradient or for orthokinetic flocculation, any one you write.
Okay, ma'am.
Okay. And a mixing device. So mixing device means, what did I say? What is meant by mixing device? The last sentence you would have heard means you would answer to me. What is meant by mixing device? Mixing device is nothing but what?
Flocculator.
Flocculator, that's all. Okay. So now we are going to talk about several types of flocculator or mixing device, which depending upon the mixing devices are available in the flocculator. Such flocculators and their mixing methods are now briefly discussed. One is hydraulic flocculator, and many hydraulic flocculator, again it is being classified into two types, that is horizontal flow buffled flocculator and vertical flow buffled flocculator. And the second one is hydraulic jet action flocculator, and next one is Alabama type flocculator. These four are coming under this buffled type flocculator, that is hydraulic, operating under hydraulic flow. Hydraulic flow means due to the pressure difference how the system is working. Based on that, it is classified into four types: vertical flow, horizontal flow, hydraulic jet flow, and Alabama type. The Alabama type, because the place in America they have found this particular type, so that is called Alabama type. So all the type I will give brief. And the next type is pipe flocculator, pedal flocculator, pebble bed, fluidized bed, pneumatic flocculator, surface contact flocculator, PVC flock model, inline flocculator, sludge plant clarifier, tapered velocity gradient flocculator.
Ma'am, we have to remember all these.
Yes, sir, that's what I'm telling you. Just remember all the types of flocculator. Instead of 10, you can 8, 9 also okay. About each type, you write 1 or 2 lines, it's enough.
Ma'am will get so confused.
Ma'am, this subject is only so chapter is
Yeah.
also
This complete
so
chapter is so confusing, ma'am.
Okay, now I will tell you. Suddenly, I will take you. I will leave you in my kitchen. Will you be confused or not? Even though you know the cooking. Can I take you and leave my your kitchen? You will please cook for today. I will leave and go. What do you do?
Can't understand what you're saying, ma'am.
Oh, ma'am, your voice is very low.
Okay. What I'm saying, yes, it is confusable one day, but you have to understand the concept. So now I am talking about the flocculator, which is nothing but a mixer. This type of flocculator classified based on the type of mixing device used in that. According to the hydraulic, according to the flow, it is being classified many types. Whatever I said, it is hydraulic type, pipe type, pedal type, packed type, bevel type, fluidized pipe, Pneumatic type, surface contact, PVC. 1, 9, 10 you write. About the each one, I am going to say few sentences. If you read out everything, your mind will be break. That's what I am telling. Why I am telling? If I take you and I leave you in my kitchen, I will tell you, okay, you cook and leave. Will you be confused or not? Because you do not know what is what, where it is.
Yes, ma'am.
But you know the cooking. Understand? Like that only. Now you don't know because first time you are looking it is like that. If you read 1 or 2 times theoretically, just then you get some idea, then you cannot write out. So for that, I am going to give hints how to read, how to find out what to write.
Okay, ma'am.
Clear? Okay. Okay. So there's a hydraulic type regulator we will discuss now. Hydraulic type again I told you already I told you that this is again classified into 4 types according to the flow. The horizontal flow, next one is vertical flow, next one is hydraulic jet action flow, then Alabama type. What is meant by horizontal flow? Actually, what is the name? What is the description inside? It is something different only. But a few steps that you can remember and write. Horizontal flow means here a typical horizontal flow is occurred and which consists of several around n buffles between space not less than 0.45 meter to permit the cleaning between the buffles to buffles at the end. And they have provided some clear distance and each of the buffle they are supposed to be cleaned frequently and about 1.5 times the distance between the buffles but never less than 0.6 meter they are maintained. In this particular type, they have to maintain particular velocity and the detention time is supposed to be 15 to 20 meters. The velocity is 0.1 to 0.3 meter per second. This kind of flagulator, you have tried what you have tried now. Horizontal flow buffled flagulator, which
Man,
has
in this horizontal flow buffel flocculator, the diagram is shared over here. One.
Correct only because horizontal means what are they have provided in horizontal flow.
So where is the mixing done here, man?
I am telling now the horizontal flow by the name, the inlet and outlet are in same position. The bubbles are there now, the water is flowing from each bubbles up and down, up and down, up and down. There will be a turbulence.
Yeah.
Now.
Yeah,
because of the turbulence, it is getting mixed.
Okay.
Clear?
Yeah, ma'am. Got it.
Okay. Here the velocity is a 0.1 to 0.3 meter per second supposed to be maintained for the detention time of 15 to 20 minutes. At that velocity, that detention time is very important. This is suitable for small water treatment plants. It is easy to drain and clean and the head loss can be changed as the requirement altered in the number of buffles. But anyhow, the dead space between the wall and the buffle is supposed to be maintained 0.45 meter. That is very, very important. You should know that. And vertical type buffled flagulator. Here you can see the vertical flow. What could be the difference between the up and down? Did you understand? What we have seen that horizontal flow and vertical flow. Any one of you can see after seeing the figure?
The opening, ma'am. There is a small opening.
Where?
The length also.
Vertical flow.
Yeah.
But in
only gives some sort of turbulence. Clear? That is only the difference, nothing else. The water entering and bubbles, everything is same. Because of that small opening, the vertical flow, which gives some sort of forcing into the water, which pulls the water upward or vertical. That's what it is called vertical flow. Here also they are giving some design parameters for operation. The velocity is supposed to be maintained 0.1 to 0.2 meter per second. In horizontal flow, it is 0.1 to 0.3. Here it is 0.1 to 0.2 meter per second. There in the retention time 10 to 15 to 20 minutes. Here 10 to 20 minutes. You remember like that only, no other thing. Okay. Then hydraulic jet action. Hydraulic jet action by the name itself we can easily understand. Here it is the coagulant is injected into the raw water using a special orifice device. So it is called the hydraulic jet action. Again, I will.
It is injected in what, ma'am?
Injected into the raw water line using a special orifice or nozzle at the inlet.
Can you spell it, ma'am? What is it?
Injection. We are giving the injection.
Inject in what?
Raw,
Injection of
RAW, raw water.
Raw
Injection
water.
of
Okay, fine. Yeah.
no, injection of alum or coagulant.
I got it. Raw water. Yeah, ma'am.
Okay, into the raw water line by some orifice or nozzle at the bottom. So the proper mixing is taking place due to that injection. So which makes a jet flow at the inlet. So there is a possibility of mixing is taking place at the inlet itself. So that is called the jet action plug later. Clear?
Okay.
Alabama type plug later. Actually, this is also comes under this hydraulic type. Here the water flow from one chamber to another chamber entering each adjacent partition at the bottom and which enter through outer the facing upward. Here it is initially developed in the place of Alabama state in US, so the name called the Alabama type plug later. Here also there is a detention time, depth, velocity, everything they have given the physical reality. You just use it. Only the difference of technical point you have to mention. Remember that water flows from one chamber to another chamber, entering each adjacent portion at the bottom end through outlet facing upwards. Through the outlet only from one portion to another portion enter. Then it is easily enter into the outlet which is facing upwards. That is the concept. Where it is mixing because of that upward flow. The next one is pipe plug later. From the name itself, nothing can be explained more, but the turbulence is supposed to be created for mixing. Anyhow, mixing means turbulence only now. Yes or no? Mixing means what? We are creating some sort of turbulence to the solution. That is called a mixing. How the turbulence can be created in the pipe? We are using telling pipe plug later. From the name itself, we can say that is a pipe. How it creates? How it creates means the flow through a pipe can create some velocity gradient. How we can create the velocity gradient? You have to increase the velocity sudden and decrease the velocity followed suddenly. Then there is a pause. Again, you have to increase the velocity of flow. Then which creates some turbulence in the pipe that is called pipe plug later. Is it clear? It is not that is clear in your book. If you have doubt, please ask me. Pedal plug later. From the name itself, here also we can say what is meant by pedal. Pedals. Now only we have seen what is the pedal, impeller, everything. So the same concept is applicable here also. The shape of the container also affects the process plugulation. Here different types of shapes of plugulator people are using. For the same volume and the height of water in the container, several shapes such as circular type, triangular type, square type, pentagonal type or hexagonal type, whatever it may be, the type will be used, but the volume and the height of the water in the container should be the same. It was observed that many types are available, but pentagonal shape only gives the best performance. And the introduction of Saturn in the plugulator helps to improve the performance of plugulation in terms of mixing. And somebody else, Polasek, one person, he introduced the pendulum type agitator in the same type of plugulator. But it is a type, different type. The motion of the blades is through the small arc which increase the distance down the pendulum, which gives the support for the mixing. Nothing more than that. Then a bevel butt plugulator is one of the important type of plugulator. In this, it contains some bevels. Bevels means what? Can you tell me anyone of you can tell?
Pebbles, ma'am. Small stones, ma'am, with shiny surfaces.
Yeah, those are all called bevels. Those bevel bed bevels can be used for this flagellation process. That can be the material for some of the flagellators, so it is called a bevel bed flagellator. This contains some bevels of size range from 1 millimeter to 50 millimeter. The smaller the size of the particle, the better is the efficiency of the flagellator, but faster is build of the health loss. But the depth of the flagellator is between 0.3 to 1 meter. It's supposed to be maintained in this particular type. But this type of flagellator does not recover any mechanical device or electrical power, and the operation maintenance cost also very low. Therefore, this type of flagellator is useful and helpful for the area like rural and undeveloped or developing countries. However, which have all the flagellata has some head loss. So we cannot consider that as a very big problem of flagellata. And the next one is fluidized bed flagellata. What is meant by fluidized bed? Only you say what is meant by fluidized bed.
Fluidized.
What means? Fluidized means liquidized. Fluid means it is liquid, ma'am. The fluidized means maybe fluidized means it is something related to water flow or fluid
Ma'am,
flow.
liquid sand.
Fluidized. Some
Fluidized.
liquid flow bed, ma'am. Or liquid is added. Some fluid is added.
Nubia, would you remember?
Yes, ma'am.
What is that fluidized bed?
Don't remember, ma'am.
Ma'am, we have used in the air. It is
Okay. Fluidized bed means fluid means what? Fluid means what?
Fluid means liquid flow, ma'am. Liquid, any type of liquid.
Fluid means either gas or liquid. Those both
Okay.
are called fluid. Okay.
yes, ma'am.
Yeah.
Okay. What is the difference between solid, liquid, and gas? Main difference. Like this, I will ask. What is the difference
The
between
state, ma'am. The state which we get.
liquid, gas, and solid? State.
What, ma'am?
Difference.
Ma'am, solids are rigid in structure and
The shape.
liquids and gases are called as
The shape,
fluids,
yeah.
ma'am, which can flow.
That's all. Now, whenever this fluids and the solid, the difference is what she said. It is correct. About that only I'm going to speak. This solid also sometimes behaves like a fluid. Okay. Sometimes the solid particles sometimes behaves like a fluid. Where this behavior is occurring in a device that is called fluidized bed. Okay. You take some solid in any cylindrical column and you pass the air from the bottom, and what will happen? Those small solids will be moving from the bottom to top. It moves like a fluid, so that is called fluidized bed. Got it?
Yeah.
Understand?
Okay.
You take any cylindrical column. The thing is, you do not have any lab facility.
Ma'am, your voice is getting very low, ma'am.
My voice is getting, my throat is paining. Like, okay, now?
Yes, ma'am.
Okay, fine.
And your mic is very far from your mouth, ma'am.
Yes,
Maybe
ma'am.
that is why we
No,
cannot hear
actually,
clearly.
when I'm keeping in my hand, it is fine. When I wanted to explain by over involvement, I leave it and I'm losing my hand. No, that is the reason. So I'm losing my conscious sometimes. Sorry. So I hold it nearby me now. Fluidized
Madam,
bed
keep
means
ma'am, you can keep some pile of books and then mic on that so that it will be near your mouth and your hands will be free.
I have to use some color as well. People are giving nice ideas.
Ma'am, you'll be having one peanut
You
to
can
keep
bring
it,
some
ma'am.
dabba from kitchen also, madam. You can bring some dabba from kitchen also.
You can pin it to the saree, ma'am. We'll do like that only.
That is a good idea that I forgot to do. Now I am doing.
We can use fluidized mic, ma'am.
So what do you mean by fluidized? Now I will catch.
It will slowly move, ma'am.
It will move means you cannot get no.
Yeah, slowly move closer, ma'am.
No, that means you didn't understand what is my fluidized.
The solid fluid, no, ma'am.
Yeah.
Yeah.
Oh, you want me to be fluidized or you want me to be my mic to be fluidized?
Mic.
Okay. Leave it. Now we'll come to the
This
point.
is the same type what we saw in pyrolysis.
There also I have told about fluidized.
Yes, ma'am. Yes.
So you should understand what is meant the different types of bed. The different beds can be used for different process in which is required based on what type of product you are going to be handled or operated. Understand? Fluidized bed, bubble bed, packed bed will be useful for any heating process like gasification, combustion, pyrolysis. And the
yes.
same things will be used for this kind of flagellation, coagulation, everything. So what is the basic funda, basic principle of each type of bed you should know. Packed bed means you are packing everything and doing the reaction in the reactor or in the cylindrical column. Fluidized bed means you are making the bed fluidized by of solid material. How it will happen? Fluid means it which will be flowing easily like water and gas. Likewise, the solid also we are making to behave like a fluid. How we can make it like a fluid? You take a solid in a column, you pass either air or gas, any gas, then the particles will be started moving like a fluid in the column. Then that behaves like a fluid. So that bed is called a fluidized bed. The same concept is applicable here also. In the fluidized bed flagulator, they are using sand bed. In the sand bed, which gives the expansion of 10% of sand, which create the required turbulence in that column without any extra media. Extra media means any other sand or something else. Here that sand size is very important, 0.2 to 0.6 millimeter of sand particle only can be used. Flow of water is naturally upward, no need to discuss much about it. And it does not require any electrical or mechanical device. Further, there is no buildup of any head loss also, because there is no, here the water is not clogged for long time. So head loss will not be here. Again, I am telling you, in this fluidized bed flagulator, they are using sand as a fluidized bed media. And in that media size is around 0.2 to 0.6 millimeter size sand particle they are using. The water is flowing from the upward. Okay. So naturally when it is flowing upward, because of that turbulence which is created by the sand particle in the fluid bed, which gives the turbulence in the column, because of that the mixing is taking place in the fluidized bed. Is it clear?
Yeah, ma'am.
Okay, fine. The next one is pneumatic flagulator. Any doubt if you have also, you can ask me. If I jump into the next topic, if you people have doubt, ma'am, 1 minute, I have doubt, you ask, I will explain again. Okay. Instead of that, don't keep quiet. Next one is pneumatic flagulator. Pneumatic flagulator means what? Here the people are using air bubble as a media to make the turbulence. How they are making? Here air bubble, they are through the suspension, they are creating the velocity gradient inside the flagulator. Because of that, simply the air bubbles cannot make. That will give air bubbles we are introducing into the system means we need to have some air compressor. Yes or no? Yes or no? How will introduce the air bubbles into the system? We need to make air bubbles means we need to have some compressor, isn't it?
Yeah,
Yes, ma'am. Yes, ma'am.
Okay. So that is the concept. In that concept they are making and giving the velocity, providing the velocity gradient inside the flagulator. So what that mixing is taking place. Another one is surface contact flagulator, which is very, this type of surface contact flagulator is developed by Indian only, which is developed especially to overcome the inherent problem of sludge choking in the previous bubble pipe flagulator, fluidized bed flagulator, pneumatic flagulator. All this type of flagulator has a problem of head loss. To avoid that, only surface contact flagulator is being developed. That is being developed by only Indians. How it works? Actually, which has some stud plates. In the plates are provided in a zigzag manner, and through the zigzag manner they are making the flow, and in a different material and a different angle they are making that zigzag fashion, while they are making the continuous flow through the downward direction. Then that makes some velocity gradient like vertical flow in the hydraulic type. Then the mixing is taking place. This is the concept the surface contact flagulator is being worked. And the PVC flog model. PVC means what? What is meant by PVC?
Polyvinyl chloride. Ma'am.
Okay, the polyvinyl chloride flog model means what? They are using that kind of material to make the bevel bed flagulator. What is meant by bevel bed? I said bevel bed. They are making bevels, different sizes of 1 millimeter to 50 millimeter size of bevels. And when they are using, there is no requirement of any mechanical and electrical devices. They are operating a maintenance cost also nil, and there is a buildup of head loss which can be removed. To overcome that, only surface contact flagulator they have developed. The same thing they are using the bevel bed flagulator to avoid that. Bevel bed flagulator has the problem of head loss. To avoid that, they are developing the PVC type. In the PVC model, they are using the different types of physical parameter like model size and pipe size, and they are providing particular angle and the number of trays, layers, how many they are using, and everything they made. The fabricated layers are then tied up by copper wire. That is very important. They are using PVC pipe of number of model, and each model they are making particular angle, and that angle how much it could make some layers. All these are tied up with the copper wire. Then such layer covers 100% surface area by the PVC angle at the 45-degree slope. Then when we are passing through this liquid in that manner, there is a proper mixing is taking place. But the depth of the flog, this model could be from the 2 meter to 2.5 meter. They are maintaining for the detention period of 15 minutes. That is important. Okay. Then inline flagulator. We have seen line blender. Could you remember? We have talked about when we are talking about this mixing device, inline blenders. Like that, this inline flagulator also is there. Actually, this is a relatively very latest model people are saying. This is working under the gravity and it is static, it works. And this type of flagulator which has very less head loss compared to the other type of flagulator. Only it is occasionally flushing is necessary since the deposition of some flag are taking place. Otherwise, the operation and maintenance of rest of the part of this flagulator is something like a normal flagulator only. Whatever the point I said, that is important. It is static flagulator, it is inline static mixture, and it is working with gravity main only. It is static, very important static. And it has very less maintenance cost, and almost the operating cost and other maintenance cost is nil. Only flushing is required because of deposition of flag, and even though the flag deposition is very less in this particular type. Sludge blanket type clarifier. Actually, till now we are talking about the flagulator or mixer we have used. We have not used the term clarifier. But when I was talking about the clarifier, I told you people, sometimes this coagulation, flagellation, and the clarification, all the three processes can be done in the same unit, I said. Could you remember? No. Now can you hear my voice with uniform sound?
Yes, ma'am.
Yes, ma'am.
I have tied up somewhere. That's what I am asking. Okay. When I have taken about the clarification process, I have mentioned that sometimes all this coagulation, flagellation, and clarification process can be taking place in the same device itself. I told you, could you remember?
Yes, ma'am.
Okay, that type of flagulator or clarifier only I am going to talk now. Actually, sludge blanket clarifier, which include both flagellation and clarification process taking place in the same unit itself. Actually, they are all very candid type. The different problem involved in this conventional candid type of clarifier or in connection with the dosing and the mixing only. Dosing, mixing, removing of sludge, and the stability of the blanket, this only. But in this particular unit, Indians only made an attempt to rectify whatever the mentioned problem, so that the sludge blanket clarifier is being modified. So the problem of dosing, mixing, sludge removal, and stability of the blanket will be reduced. How they were done means, they have done both the flagellation and clarification with the same unit. but they have done the coagulation separately. So water into the adding into the chemical. After chemical adding, they are putting into the separate unit that there the coagulation and clarification is taking place. That is called sludge plugget clarifier. And the next one is tapered velocity gradient flagulator. This is something different type of flagulator. Here, a low velocity gradient is generated, and based on that, the efficiency of this particular unit of flagulator is increased by doing some of the thing, by increase in the range of velocity gradient, and there is a gradual decrease in the velocity gradient, and no sudden jumping, and dual tapering. And when you are doing all those things, that increase the efficiency of this particular flagulator is being increased. If you provide the highest velocity gradient for the shortest time and followed by the lowest value of velocity gradient, then automatically the turbulence will be created in the sudden period of time for a higher turbulent velocity for a short period of time, which gives better mixing of the product. So the total operation time will be reduced in this particular type of flagulator. This is the reason which increase the efficiency of flagulator. So that is called tapered velocity gradient flagulator. So I have told about many flagulator. How many you could remember, how many you cannot remember, I don't know. But you supposed to remember all type. From the name itself, how much maximum you can write by your own, you please try to write. Other thing, you technically 1 or 2 sentences you study and write.
Ma'am, specifically anyone they will ask, madam, specifically.
No, they will ask the type of flagulator, write about the mixing device in flagulation process, or sometimes they ask about what is the type of flagulator. What are the types?
Okay, ma'am.
Okay. So that's what I'm telling. First 10 lessons, I will make you people to perfect, then you can easily go ahead. So did you understand what I have spoken today? Or is something
Yeah,
like
ma'am.
or it is something like a story?
Almost understood, but not completely, ma'am.
No,
Yeah,
should
ma'am.
revise this,
We
ma'am.
got the concept, ma'am. I think we
You
need to
should
revise
read.
2-3 times.
We should read,
I
ma'am.
know what I would like to advise you people. You study by today itself. It take another half an hour to complete the entire.
Yeah, ma'am.
Then you can remember many things. If you have doubt, meanwhile you can contact me by next class or in the middle. Also, I'm giving all sort of freedom to you all. I told you don't call me, don't ask me. Only the class hours you have to speak. I never said. If it is subject
Yeah.
doubt, you can approach me. But today itself you read. But after 10 days you read means you may forget all the new stuff.
Yeah, ma'am.
Understand? Actually, what is the course style of your course now? You have to read your book. You have to come to the class. You have to share your idea. And if you have any doubt, we have to clarify. That is the style of your course. Understand? So
Yeah, ma'am.
because I am advising. I thought now you go through it. If you have doubt, you ask me. It does not mean that you won't get doubt. You will get doubt. So the entire lesson now I will sum up you. Then you people, because some of the things are repeated, you will also be confused on it. This is a kind of process, sedimentation. It is one of the important. I will sum up the lesson. We have only, how many minutes are there?
7 minutes. 7 minutes, ma'am.
Hello.
Ma'am, we are not able to hear
Ma'am,
you.
can't hear you.
I think ma'am disconnected.
Shit.
No. Wait.
Yeah.
Can you hear me now?
Yes, ma'am.
But bring it little closer, ma'am, so we can hear more.
No. Not something they are doing. During the transcription, something is live. Who can see this transcript? Okay. Something they have modified, so my mic has something happened. Okay, leave it. Now, today class, 2 classes we were talking about sedimentation, isn't it? What is meant by sedimentation? It is a process of settling down of the particles are little heavier than water They are very near, fine particles called collider particles will be settled down by gravity process, natural gravity process, and also by some chemical process. Natural gravity process is called plain sedimentation. By make use of some chemical, that process is called coagulation process. This settling is happening based on the concentration of particle in the water, four different types. That is discrete and flagellant, hindered type, and composting type. Discrete type individual particle is involved without interparticle forces or disturbance. Flagellant settling is taking place with a dilute suspension of concentration with interparticle interaction. Hindered particle is happening. The hindrance will be there between the particle when the particle is being behaved like a fixed position with respect to another, then the settling will happen. Compression settling is happening when the concentration of particles more, which makes the mass of flux that is in the form of volume. Here, all four type of settling is taking place simultaneously. Okay. Then what is meant by flotation? Flotation, you know that the particles will be separating out the flotation through whenever the gas or air bubbles introduced into the water, which absorb the solid particle present in the water, then carries and which moves up by the natural buoyancy force. It will be floated on the surface of water will be removed. This will be done by dissolved air flotation, vacuum flotation, and chemical addition. Then what is meant by plain sedimentation? That is called a theory of sedimentation. This what is meant by sedimentation you have to write, and the factors affect the sedimentation you have to write, that is shapes, size, and the specific gravity of particles, velocity of flow, viscosity of flow, and what are the different shape and the size of the sedimentation tank. Then followed by sedimentation with coagulation. Then what are the chemicals can be used for this coagulation process? And the coagulation means which is nothing but adding of chemical into the water. And after that, after adding, it has to be mixed. The mixing is very important. How we can feed and mix the coagulant in the water, which is nothing but coagulation, flagellation process. That will be done by buffle type mixing basin and a flash motor or agitator type. How they will do, I have explained. Then what are the factors which affect the coagulation, and what is the purpose of doing this coagulation, and the dosage of coagulant and the conditions like pH and water. Then we have talked about what is the sedimentation with flagellation. Sedimentation with the flagellation, which is actually flagellation means it is something like a very slow mixing process in which destabilized colloidal particles are brought into intimate contact with each other to promote their size into or agglomerate their size into bigger size. And the flagellation process will be affected by physical and some of the physical and chemical parameter. I said that the physical.
Ma'am, your voice is very low again, ma'am.
The flagellation means
Yes,
flagellation will be affected by physical, some of the physical and chemical parameters. What are the physical parameter and chemical parameter we have seen? Then what are the rapid mix units? Mechanical mixer, diffuser, and injection device, inline blenders, hydraulic mixing are there. Then we are talking about the flagellators. Flagellators again, again it can be classified by the flow direction. Many type of flagellator are there. Flagellator are nothing but mixing device. What type of mixing is taking place? Based on that, flagellator is divided into several types. Hydraulic flagellator, pipe flagellator, pedal flagellator, bevel bed flagellator, fluidized bed, pneumatic, surface contact, PVC, inline, sludge blanket, tapered velocity gradient. In that, hydraulic flagellator again is being classified into vertical flow, horizontal flow, jet action flow, Alabama type. Then about each type you write 1 or 2 sentences, it is enough. But I am telling confidently, the past 3 lessons, lesson 3, lesson 4, lesson 5, almost 30 to 40% of question made. Understand? But
Yeah, ma'am.
everyone,
Yes, ma'am.
Okay,
has
ma'am.
different mood. Okay. So all the best to every one of you. Just to go through it today itself. If you have any doubt, you please contact me. Anything else?
Ma'am.
Okay, ma'am.
No, ma'am. Thank you.
Thank you very
Thank
much,
you,
ma'am.
ma'am.
Thank you.